Chain, chain, chain. Chain of letters. How do you do? It's Mr. Moo. How you doing? This week I took a break from working on my game Stolen Hearts to participate in the Chain Letter Jam. In this video I'm going to be taking you through the creation of my game Road Snake. I'm going to be explaining a basic computer science concept that I used to make it. So if you're interested in computer science or programming but never had an opportunity to take a class, you might be interested in sticking around. The Chain Letter Jam is a different type of game jam, originally created by Miziziz, in which he made a game and then nominated other people to make a game based on his game. When they finished their game, they nominated a couple of other people, and thus the chain continues on. Right off the bat, I'm nominating Tauheed Game Dev and Skeffles. Skeffles has just released Project Torrim, a game he's been working on for over a year now, and it's releasing today. So go check that out, and Skeffles, now you gotta make another game. I was nominated by TheShelfman, who created Rock Letter Boom. In his game, you control this little pixel person driving a car, trying to avoid smashing into roadblocks. At the same time, you have to use your mouse to select letters and spell words that pop up on the screen. However long you last is your score. There's plenty to work off there, but the idea that I want to base my game on was rather than trying to avoid blockades with the car and then spelling words with the mouse, you would just drive the car into the letters to spell the words. And when I was trying to determine how the car would actually move, I decided just to keep it the four basic directions: up, down, left, and right. At the beginning of the game, a word would appear at the top of the screen, and then the letters to spell that word would be randomly scattered around in the drivable area for the car. And your job as the player is to pick up all of the letters using the car in the correct order. And since this is the Chain Letter Jam, every time you pick up a letter, it would be added to a chain on the back of the car. So at this point, I was just kind of recreating the classic game Snake. So, as I always say, in for a penny, in for a pound. So I implemented all of the Snake mechanics and all the Snake rules in which you can't crash into walls and you can't crash into your own tail. I also added the twist: if you tried to pick up a letter out of order, you would also lose as well. The way I actually implemented the chain and the way it moved was using a computer science / programming concept known as a linked list. A linked list is a data structure in which a series of nodes are connected to each other by one node referencing the next. A data structure is just a way to organize information and store data. But in this case, I'm using it actually less as a data structure where I'm storing information and more as a physical asset in my game. So let me show you what I mean. The car is the first node or link in the chain of the linked list. This is known as the root node. So attached to the car is a script called chain, and this is my node script. So for now, just focus on the variable next in the script. That variable references the next node or chain link in the sequence. Since the car is all by itself, next is null, meaning that it doesn't refer to anything. That also means it's the tail or the end of the chain. Now let's say the car drives over a letter and we want to add it to the chain. Well, the script says take the letter, which also has the chain script attached to it, and add it to the tail, the last link in the chain. So what's the tail? The tail is the only node in the chain in which the next value doesn't point to anything, right? That next value is null. The method, or algorithm, I use to determine which node is the tail is very simple. I start with the root node, the car, and ask, do you have a next? If it does, I move on to the next node and ask the same question. And I'll continue doing so until I find the node without a next. I know I'm at the tail, and so I set the next to be the new letter. So when we just have the car, it's both the root node and the tail node. So I ask the root, do you have a next?
No.
Set the next to be the new letter and we're done. Let's add another one. We start with the car. Do you have a next?
Yes, I do.
So we do the same thing with the next node. Letter A, do you have a next?
No.
So we set it as next and we're done. So now the letter B has no next, making it the tail. One last time. We ask the root node, do you have a next?
Yes.
Then we ask A, do you have a next?
Yes.
We ask B, do you have a next?
No.
So we set C as next for B and we're done. So why do I bother implementing like this? So let's look at the way the snake actually moves. Every node moves to the position as the one before it did. So moving this way is actually quite simple using a linked list. The way I implemented movement is quite similar to the way I implemented adding to the tail. I store an extra variable of vector2 called last position on each link of the chain. So we know the current position and the last position. And so when we want to move the car, we set the last position to be the current position, and then we move the current node to the new position. And then we tell its next to move to the current node's last position. And we keep doing this until we get to the end. We traverse our way through the linked list, passing the next position for each node. So the snake train is actually a visual representation of what a linked list actually is, which is one of the first data structures you would learn in school if you were taking classes. You might be saying to yourself, well, I can accomplish the same thing using an array list or some other data structure, so why would I use this instead? And you're right, there are many ways you could have accomplished the same thing. If you're interested in learning more about why you would choose one data structure over another data structure from more of a theoretical standpoint, you should look into big O notation. Now, if you already know what big O notation is, I know what you're saying.
If you really care about big O notation, then why don't you just keep track of the tail? You can add to the tail in constant time rather than O of n if you already know what the tail is.
And to that I say, because this is a free country. I hope that wasn't too technical for you, and hopefully you learned something if you didn't already know about linked lists. Let me know in the comments below if you like this style of video, or if this was too deep in the weeds for you, or this wasn't interesting at all. This channel is almost at 100 subs, so I would very much appreciate if you hit that subscribe button and the like button too while you're there. Who knows? Also, link to my new Discord in the description. Also, wishlist Stolen Hearts on Steam. Okay, anyway, see you in the next one.